Hey, here is part D, and the question is, what is the maximum distance between Mary and Chance over the time between 0 and 20? Okay, and then justify your answer. Okay, so we need to know the maximum distance. Okay, so the first thing that we are going to do is we know that this is kind of right above part A. The last sentence before part A says Mary is 12 meters ahead of Chance at time t equals 0. Maybe I can just go right to here. It's right on the right side. Mary is 12 meters ahead of Chance at time t equals 0, and Mary remains ahead of Chance the whole time. So we want to know what is the maximum distance. Okay, so we're going to say what is the maximum distance? That's the question we're answering, right? Well, we know at time t equals 0, the distance is 12, right? We're probably going to end up making a table like they ask us to do a lot of times on these free response questions. So we want to say, does 12 factor into this? We want to know time t equals 0. We need to say, what about time t equals 20? What is the distance for that one? And then we need to look for other times as well, right? That's what we're really going to be looking for. So what we want to say is the distance between, we're going to say the distance between m of t and c of t. Okay, that means we're going to find the distance, right? So when we say distance, you know that m and c, I can't really find a distance between these two things because these are both velocities, right? Oh, that's a great way of spelling velocity. Let's try that again. Velocity, there we go. So we have a distance, or we have a velocity functions, but we're looking for the distance. So if you remember, what we need to do is we need to take the integral. And if we're trying to find the distance between them based on what we did for part C here, we subtracted them, right? So since we're subtracting, we're going to try and find the integral. Now, what we need is we need the integral from 0 to t, right? Because we're saying the distance between here is going to be the maximum. So we're saying at different points t, so our ending point is going to be a different spot. We want to find out where is their difference going to be the greatest. So we need to stop here, which means when we do this, when we do like we did for c, where we take m of 18 minus c of 18, we're going to, right here, we are going to try and do that. But now we need a different variable. So it's just going to be, let's say, m of x minus c of x dx. And then why are we doing a different variable? Because we're saying at time t here is when we're stopping. We're starting at 0, time equals 0, and we're ending at some time t, where we'd probably want to say like t is less than or equal to 20, right? Because we want to find out when is that distance going to be a max. So that means that's why these variables, these x's, are not the t's that we need, okay? So if you remember, if we want to be able to do this is the second fundamental theorem of calculus. We can say d of dt is really what we're going to look for. Ooh, there's one other thing I need to include. Now, it's not a big deal, but I should say we also start, if we're talking about distance, we know that Mary starts at 12, right? She starts at 12, and then we're going to add the difference of their distances. So if she's traveling faster than Chance, after they first start out, her distance is going to increase from 12, right? So we do need to say she starts at 12 because her distance first is 12, and then from there, we are going to move on. Okay, so if you remember this whole thing, the fundamental theorem of calculus part 2 says if we take the derivative with respect to t, all we really do is just plug in the t here and we plug it in there, right? So that whole thing is just going to be m of t minus c of t. Okay, so we want to find m of t minus c of t, and we're going to say, when does that equal 0, right? Because that means their velocities, we want to say, when are they equal to 0? When do they equal each other? Because that's going to give us time for either maxes or mins, right? If our velocity is 0, that means we have some sort of max or min situation, all right? So what we're going to do is we're going to go straight to Desmos and look at that. I graphed them, so it didn't take us a long time, and I didn't have that same problem of trying to type it all in before. Okay, so we could say their distance is going to be 12 right away, or we could say we need these 2 times of when their distance is the same, when they are equal to each other, when m minus c equals 0. Okay, so what we're going to do is we are actually going to make a little chart. We're going to say we need time. Oh, there we go. And we also need distance. So we have to remember our endpoints, 0 And then we also have to remember 20. And we know that this happens at 2 points, 4, 5, 8, 4. So we have 4, 5, 8, 4, 4.584. And the other one was 16.715, 16.715. Okay, so those are our 2 times where that could happen. And I know at time 0, the distance is 12, and then we have to plug these in. So how do we figure this out? Well, this distance is just going to be m of 4.584. So we're going to plug into Mary's minus Chance's value at 4.584. And then the same thing for this one. Mary's velocity at 16.715 seconds, subtract Chance's at 16.715 seconds. And then at 20, it's going to be the same thing. Mary's velocity at 20 minus Chance's velocity at 20. Okay, so when you plug those in, remember what the formulas are, the equations are for each person. We say that Mary's, well, I think Mary's I put in blue. M of t equals 610 over t squared minus 3t plus 50.5. So just plug these numbers, and these numbers in for there. And then we have Chance's function. I'll write it down here one level. C of t equals 8.5 t cubed e to the negative 0.45 t. So you're going to plug in 4.5, 16.715, and 20 in for those t values. And then you have to subtract that one from this one. Mary's from Chance's. And I will just write down what those numbers are so that way you can check to verify you get the same thing. This one should be 365.52. And then this one is about 13.3. And the last one is 27. Okay, so that means if we have to answer the question, which was asking us what is the maximum distance between Mary and Chance over this time interval, we will say that the max distance is 365.52 meters, right? And that occurs at t equals 4.584 minutes, not seconds, it's minutes. Okay, so I think we've justified our answer. We've shown this table. We've tried the endpoints, which sometimes they're always, well, I shouldn't say sometimes they are looking for, right? They're looking for those starting and endpoints and these 2 spots in the middle, and then you just have to plug it into your calculator to see if you can get the same values that I did. All right, so that concludes part 1. What I'd like you to try is to do part 2. You can send me a picture either on that classroom or on that classroom site or on an email. I will try to look at it and I will try and see if I can see what you did and give you any feedback if you got it right, if you got it wrong, whatever. I will also include this entire sheet, just like I included some other stuff. That way you can see kind of what we did for part A. All right. So good luck with that. I'll probably come out with a video tomorrow just on I think it was question 3 I had said I'll try to do. And then you can try and work through those 8 questions and we'll see where you're at after that. Okay.